Hi guys. So this question solve the differential equation again. So before solving any differential equation, guys, we need to know what kind of equation it is. Okay. So the given equation is a homogeneous differential equation. Okay. So what is an homogeneous differential equation? A differential equation which is in the form of this dy by dx is equal to f x comma y. So what does this mean? This means that dy by dx will be function of both x and y. Okay, so for the given function, let's write that down and let's see if it really looks like that. Okay, so what will be the first step for this? We will move the dy by dx term to one side. Okay, because as you can see, like in the form of homogeneous equation, or even when we see a linear equation, once you get the equation in terms of dy and dx, guys, it will be easier for you to see and understand what kind of equation it is. And once as you see and see what kind of equation it is, you can proceed further for solving it. So moving the dy term, let this x dy by dx plus y dy by dx is equal to x. So now we'll move y from the left side, subtracting y on both sides. X minus y. Okay, so now we'll take dy by dx common. Okay, so when we take that, what we'll get? X plus y, right? Equal to x minus y. Let me write this, the next step here itself. Arrow indicate the next step. So dy by we are dividing both sides by x plus y, guys. So you'll get dy by dx is equal to x minus y divided by x plus y, right? So as you can see, uh, dy by dx is a function of both x and y, right? And the numerator we have x minus y divided by x plus y. So if you compare, guys, both, you can see that this is an homogeneous equation. So guys, once we have identified it, now we will assume let y is equal to vx, right? So now differentiating, we'll get dy is equal to dv by dx into x plus into v. It will be like dx by dx into v, right? So guys, we are using product rule for this. See, this is the product rule. We use it when we need to differentiate product of two functions. So cool. Now that will be exactly that will be basically v here. Okay, so let's just substitute the values we got in here. Dy by dx, I'm so sorry, differentiating with respect to x, right? So what we will get on the left side is, now we're substituting value of y is equal to vx in the given equation. Okay, so it will be dv by dx, right, into x plus v that we got from here, and our original equation is x minus y, that is vx, x plus vx. Let me just write it down. Substituting y is equal to vx. Okay, so in equation 1, so cool, let's continue. So we'll take x common, so it will be 1 minus v x 1 plus v, right? X and x can get cancelled, so we will have x dv dx plus v is equal to 1 minus v divided by 1 plus v, right? Okay guys, now what we'll do, we'll subtract both sides by v. Okay, what we are trying to do, we are trying to get x and v terms on different sides so that we can integrate. So this side will get minus v, right? X dv by dx 1 minus v minus v whole 1 plus v. This is this term, guys. Okay, 1 plus v. Minus v minus v minus v square divided by v square divided by 1 plus v. So it will be x dv by dx is equal to 1 minus 2v minus v square divided by 1 plus v. Okay, I'll just like to add one more step on the screen, that is, let's get v and x terms on each sides of the equation, guys. Okay, so if we do that, what we'll get is 1 plus v 1 minus 2v minus v square dv is equal to dx by x, right? So guys, what we had here, we had it was 1 plus v divided by 1 minus 2v minus v square, right, dv, and here it was dx 1 by x, you can write it like that. So what we'll do now, we'll integrate both sides. So integrating both sides, guys, as you can see on the left side, guys, the denominator is not we can't factorize it, right? So we'll use this method. Let's see, 1 plus v, we are just working on the left side at while. Okay, so that can be written as a 1 sec t of minus 2v minus v square dx plus b whole divided by 1 minus. So what we are trying to do is that we are trying to get this, get the numerator, okay, so that we can integrate this given function. So we can write 1 plus v is equal to a into, the differentiation of this term will be, guys, 1 minus 2 minus 2v plus b, right? As the denominator is same, we can just equate, right? So from this given part, let me write one more step. We can write 1 plus 2a plus b minus twice ab. So now what we'll do, we'll see the coefficient. Okay, we are going to compare the coefficients. I just opened the bracket in the next step, guys. So as you can see, the coefficient of v here is 1, right, and here it is minus 2a. Okay, so when we compare, we can write it as 1 is equal to minus 2a, right? That will give us a is equal to minus 1 by 2. And we can also see that 1 like constant, when you compare the constant on both sides, Okay, so 1, I'm sorry, 1 is equal to minus 2a plus b, right? So as a is minus 1 by 2, so minus 1 by 2 is b, so 1 plus 1 plus b, right? So when we then we get that b is equal to 0. Okay, so a is minus 1 by 2 and b is 0, right? So it is like so on the right side what we have is integrating 1 plus v divided by 1 plus 2v minus v square dv, and this side we can write it as it was integration of dx, right? So the left side, as we saw the calculations we did, according to that we can write a was minus 1 by 2 in integrating minus 2v 1 minus 2v minus v square. And guys, as b was 0 we are not writing it, okay? So we can write it like this. So let's assume 1 minus 2v minus v square is t, so minus 2 minus 2v whole dv is equal to dt, right? So we can write the next step as 1 integrating dt by t. We just substituted the value of t, guys, in the earlier, like in the above step, and this is dx by x, right? So I will get minus of log t, right? So I will just write the value of t, that is 1 minus 2v minus v square is equal to log x, log x plus c, the constant. This is the answer, guys. Thank you.